Hi, this is a lesson to help students prepare for the HiSET math test. This will be the first lesson dealing with solving single variable equations. So I'm going to go ahead and get started. When we're dealing with equations and inequalities, what I want you to think about in applying algebra is that you need to recognize that every equation has a solution, and your goal is to try to use algebra logic to solve for that variable or get that variable by itself. And so that variable is that letter in the equation, and it just represents some unknown number that we are solving for. So you should end up with your last step would be something that looks like this. The variable, whatever it is equal to some number. Okay, so you're going to work through a series of steps, working down line by line in kind of an order. The first thing that you need to be on the lookout for is applying the addition principle, which uses the additive inverse. So we need to get started talking about what the heck do we mean by additive inverse. Additive inverse is whatever you can collect with a number to get to zero. And I think we've talked about it a couple times already that in algebra and math, we have different operations that are inverse operations of each other. Adding and subtracting undo each other, multiplying and dividing undo each other, squaring and square rooting undo each other, cubing and cube rooting undo each other. So we're going to be focusing on that adding and subtracting undo each other, and that is using the addition principle by thinking of the additive inverse, what undoes that. So we want to just look at a couple numbers here just to kind of practice the concept. What can we collect with a -7 to get to 0? And that would be 7, because the two of those are additive inverses of each other. What can I collect with, 5/10? And that would be -5/10, because when we collect those, that gets us to 0. We can collect -8 with a +8, and that would get us to 0. We can collect 3/8 with -3/8 to get us to 0. Now notice that if I don't put the positive there, it's implied that it's a positive outcome. Same thing here with -5.3. I can collect +5.3 to get to 0. With a fraction like 5/7, it would be -5/7. So it's basically the number, but just a different sign, because that's what happens when you collect those, you get to 0. Okay, so we're going to use that concept to solve some very, very basic single-step variable equations. So in this first one, the first row here, we've got our variables on the left side. We have a constant, this number that's on the same side as the variable term, but it doesn't have a variable with it. That's called the constant term. I'll go more into detail on that later. But basically, we kind of have the order variable number equals to some number. That is very unusual that your numbers are going to be in that order. So I don't want you to get locked into the order. I want you to hear the process, and then we're going to kind of change it up. So your first question is where's my variable? My variable is here on the left side. Next question is what's connected to it? A +2 is connected to it. And so we need to think about additive inverse to undo that. And so the additive inverse of +2 is -2. So what we're going to do is we're going to, instead of adding 2, we're going to subtract 2. Because those are additive inverses. Whatever I do to one side of the equation, I have to do to the other. So I can go ahead and work through this. Notice I'm drawing a computation line. That computation line is really important because that tells you you're collecting everything above it and bringing things down. So there's nothing to collect with our variable x, so I just bring it straight down. When I'm collecting +2 and -2, they cancel each other out. That's what makes this work. I bring down the equal sign. 11 and -2 gives me 9. And so our solution is x is equal to 9. Now I know that you could have solved that just good old-fashioned elementary math skills, but we want to practice this concept because things are going to get more complicated, and we want to have this very basic one down. On this one, we've got a variable x, +5 equal to -8. The variable is on the left side. It's got 5 added to it, so I want to subtract 5. That's the additive inverse. Whatever I do to one side, I have to do to the other. Draw my computation line, and then collect bringing things down. X comes straight down, 5 and -5 cancel each other out. The equals comes down. -8 and -5 collects to give me -13. This one, variable again, is on the left side. We've got 3 subtracted from that variable, so I'm going to add 3 to each side because that's the additive inverse. Draw my computation line. bring everything down. The m comes straight down. The -3 and +3 cancel each other out. That's why we're choosing to use it. 19 plus 3 gives me 22. Okay, on our next row, things are kind of changed up. And I really want you to recognize that it's important that you kind of go with the questions that I'm examining here. Where's my variable? That's the first question. So on this first one, my variable now is on the right side. The next question is what's connected to it? I've got -4 here connected to that variable. And I'm trying to isolate that variable, so I have to think about what undoes subtracting 4. Adding 4. Whatever I do to one side, I have to do to the other. So I'm going to add 4 to the left side. Draw my computation line. I'm going to bring everything down. 8 plus 4 gives me 12. The equals comes down, the n comes down, and these two cancel each other out, and that's what made that work. Okay, so this applies to decimals as well. So we've got we've got our variable here on the right side. I've got positive 3.4. The additive inverse of that is negative 3.4. Whatever I do to the left side, I have to do the right side, so I'm going to subtract 3.4. That'll eliminate. I draw my computation line. This is going to eliminate, bring my variable m down, and when I actually carry out my subtraction here, this is going to be 0.3. The next line, we've got fractions here. So the same thing applies. My variable now is on the left side. I've got 1/2 added to it, so I'm going to subtract 1/2. Draw my computation line. These eliminate. I can bring my variable down. X is equal to, when I go to collect my numerators here, I have -4/2. And using our fraction skills, we know that 2 goes into -4. That's going to be a -2. Come down here. I've got my variable on the left side again. I'm going to subtract 17.4 using that additive inverse. Draw my computation line. These eliminate, so on the left side I've got y by itself, but here I need to recognize I'm collecting one's positives, one's negative, so it's going to be a little different than just adding or subtracting. Because one's positive and one's negative, I'm going to have to subtract, and my sign is going to be the sign of the larger number. So I'm going to be taking 17.4 minus 10.9, which gives me 6.5. And because the negative, I have more negative here, this outcome is going to be negative. If you're struggling with that, you'd probably want to go back and take a look at integer operation rules where you're dealing with collecting positive and negative numbers. Okay, on this one here, my variable is second. It's just a little bit out of order, but it's still on the left side. I've got -7 collected with it, but I'm looking at this sign here. The additive inverse of -7 is +7. So I'm going to add 7. If I'm adding 7 to the left side, I'm going to add 7 to the right side. So that eliminates. I end up having y is equal to 20. I get to this last problem here. My variable is on the right side. It has -7.9 or 7.9 subtracted from it. The additive inverse of that is going to be +7.9, and I'm going to add 7.9 to the other side as well. Draw my computation line. These eliminate, so I have a, my variable, is equal to 19.9. Okay, so those are very basic examples where you are working with just one single operation, and that is the addition principle, using adding and subtracting or the additive inverse property to get your variable isolated on one side of the equation. Again, the questions you ask yourself is, where's my variable? Which side of the equation is my variable? What is connected to it? And then how do I undo that? Using the opposite sign. And then you go about doing that. Make sure you draw your computation line. That's just kind of a notation device to yourself as you move forward with these, that you're connecting, that you're collecting everything above that and bringing it down. Thank you very much.